Welcome to my classroom. In this video we're going to be looking at fractional relationships of your mealworms and developing our language of fractions so that we can look at part-to-part fraction relationships and part-to-whole fraction relationships. In the example I did, when I put several mealworms on paper and watched them for 5 minutes to see how many went below paper or stayed on the paper, I used 15 mealworms total, and after 5 minutes time only 4 of them were on the paper and 11 of them went off the paper or below the paper. So for this first part, it says to look at this relationship as part to whole. Another way to express that is part to total. So both of these are our parts, and we're going to be comparing them to the total. That's pretty common with how we look at fractions. Usually we're looking at part to whole relationships where we're given that value of the total. For instance, in part 1 we knew the length of the table that our mealworm traveled. So when we're writing these as fractions, the fraction on the paper would be represented as 4 out of the 15 mealworms. And the fraction off the paper would be represented as 11 of the 15 mealworms. Now, in the previous video, I showed you how to take that information and turn it into a percent. So if I'm representing 4 out of 15, let me just make a little arrow, as a percentage. Remember, percent, it's a fraction, but it's going to be a fraction out of 100. So to get the denominator of 15, there are a lot of different pathways that we can take to get it to 100. I'm going to take the most just straightforward path and think, what do I need to multiply 15 by to get to 100? And of course, 15 doesn't go perfectly into 100, but I'm going to use a calculator in this case to show you what we need to multiply 15 by thinking about it as 100 divided by 15. And so that's 6.677. So I'm just going to say times 6.67 to get out of 100, and whatever we do to the denominator we must do to the numerator. So we're going to multiply 4 also times 6.67. I'm not even going to clear my calculator. I'm just going to throw it in there, and it's 26.67%. So where it says percent on paper, I could write 26.67. Now for the percent off paper, I already know what I'm going to be multiplying 15 by because it's the same denominator. So the only difference is instead of having 4 in the numerator, I'm going to have 11 in the numerator. But I'm going to take that 11 and multiply it by 6.67 because I need to get the denominator to 100. So to do that, I'm just going to take 11 times 6.67, and that's 73.37. And you should notice, if you did your fractions correctly, they should total 100%. Because the percent on the paper plus the percent off the paper should be all of our mealworms. There were only 2 options, so that should represent 100% of our mealworms. And you could see 73.37 plus 26.67 will give us roughly that 100%. So that's how we can do that first part. For the second part, we're going to be focusing now on part-to-part comparisons, and this is something that many people haven't worked with before, and it might be somewhat uncomfortable. So remember, just as a reminder, on paper we had 4, off the paper below we had 11, and we had 15 total. Usually we've been comparing our fractions to this total, but for this part I'm only going to be looking at these part-to-part comparisons, so comparing on paper to below paper, and these can be represented as a fraction. And you can figure out what the total is by knowing this fractional relationship. You could take this and draw a tape diagram as well, and I'm going to show that on the following page. The tape diagram would look like this. You could see our total mealworms. We could have 15 parts. On paper is represented by 4 of those 15. Below paper is represented by 11 of those 15. Now let's take this to answer the questions that are in part 4 of your investigations packet on fractions. All of these answers need to be represented as a fraction. There were blank more mealworms below the paper. If in your case you had more mealworms above the paper, you can just cross this out and write there were blank more mealworms above the paper and switch the wording down so that it works for your group. But in my case this is appropriate because I had more mealworms below the paper. What fraction did we have more? Well, you can see in the diagram above, at the top we're represented by 4 of the 15. And below the paper we have 11 of the 15. So by what fraction did we have more? Well, 11 fifteenths minus 4 fifteenths would be 7 fifteenths. So there are 7 fifteenths more mealworms below the paper. 7 out of 15 more. And what that also means is there were 7 fifteenths fewer mealworms above the paper, on the paper. So these are both representing differences in our fractions. The difference between 4 fifteenths and 11 fifteenths is 7 fifteenths. 4 fifteenths is 7 fifteenths less than 4 fifteenths. Or 11 fifteenths is 7 fifteenths more than 4 fifteenths. Now for this next part. There were blank as many mealworms below the paper as there were above the paper. Well, if we go back to this previous page, I'm just going to look at this table right here. This is showing us our part. So on paper to below paper to total, on paper to below paper is 4 to 11. So I'm just going to kind of re-represent that information on, below, 4, 11. And that information is shown in our tape diagram, but when we're exploring part-to-part relationships, we're going to be representing this comparison as a fraction. So if I'm looking at there were blank as many mealworms below the paper as above the paper. So order really matters. So pay attention to that order. That relationship is 11 to 4. So we can express that, and this is where you might not have a deep understanding of this right now. I just want to get you comfortable with this language so we can use it going forwards. We can express this relationship by saying there were 11 fourths as many mealworms below the paper as there were above the paper or on the paper. Now that can't be reduced. So it is in simplest form. If your fraction isn't in simplest form, put it in simplest form. Now, in this next part of your packet, we're going to be looking at what this fraction representation is as a decimal and as a percent. But right now, the relationship, the fraction of mealworms below the paper and on the paper is 11 fourths. And the reciprocal would be true. Now we're looking at the fraction above the paper, as there were, obviously, hopefully you caught this mistake. This should say below. I'm not going to write the rest. But now we're looking at the fraction above the paper to below the paper. So we can represent this relationship as 4/11. So we could say there were 4/11s, as many mealworms above the paper as there were below the paper. So there's a smaller amount. 11/4 would show there's a much greater amount. So that's the developing your understanding of the language of part-to-part fraction relationships.